I'm going to go through this kind of fast. It says to graph this. We can graph this by hand, but we're just going to practice using the calculator on this one. So take out your handy-dandy calculator. You can just watch me. All right. Let's get my calculator out. And I'm going to graph. By the way, we should know what this graph looks like before we do anything. That's my expectation of you. Does anybody here know what this graph even looks like before we graph it? It's a rational graph that shifted over to the right, too. And it's stretched by 3. So it's going to look something like this. Just moved over twice, 2 from the origin. So if I hit zoom 6, that's my standard, and there it is. Like I said, this graph shifted over by 2. This is my phone. What do you have? iPhone?
Yeah,
it's not. Oh, Droids are good. You're good on Droid. Apple does not have this app. But it's really annoying because you have to download the app and then you have to download like other things that are very hard to find. You have to go like onto the. You have to be a pirate on the web. So anyway, looking at this graph, is this defined at 2? You don't even need to look at the graph. Could you plug this in right away? You get 3 over 2 minus 2, which is 3 over 0. Is that defined? Not defined. So this is DNE, does not exist. Alright, what about 2 from the left? If I hit the trace button, I can start moving around my graph. So let's look at the x's. So I'm to the left of 2 right now. What happens is I keep approaching it closer and closer. It starts to get very, very negative. So guess what that answer is? Negative infinity. And I'm going to start on the right and come from the right side. What am I getting closer and closer towards? Positive infinity. So what's the limit as we approach 2? It does not exist. Why does not exist? Right side. Not by, because the limit as x approaches 2 from the left of f of x does not equal the limit as x approaches 2 from the right of f of x. Alright, those two need to match. Let's talk about this graph a little bit. Now, the calculator can't show you asymptotes, but there are 2 asymptotes on here. What's the vertical asymptote? That's what I'm going to talk about the most right now. What's the vertical asymptote? It's at 2. How do you know the vertical asymptote's at 2? Because you set the bottom equal to 0. So if you set the bottom equal to 0 of a fraction, so you have a number over the denominator. Let's call it denominator. So the vertical asymptote is when we set the denominator. Is the denominator equal to 0? That's how you get a vertical asymptote. Because we're talking about asymptotes a little bit, okay? Now, if you're ever at a vertical asymptote, you only have 3 choices as your answer. Either infinity is your answer, negative infinity is your answer, or does not exist as your answer. You can just mentally think about it. Look at looking at a vertical asymptote. It doesn't just stop, unless it's a piecewise function. It doesn't just stop right there. So your choices have to be infinity, negative infinity, or does not exist. Okay? So we're gonna start doing these by hand. So I have a little technique. If you ever have a number over 0, okay, you want to check the right side and left side. If they're both positive, it's positive infinity. If they're both negative, it's negative infinity. If they're one of each does not exist. You'll see what I'm talking about when I get to this problem right here. So I'm going to do 43 first because that one's more important to me. And I'll kind of go back to those. So, find the limit as x approaches 1. Always directly plug in right away. What happens when I plug in? You get a number over 0. So we're going to check the right side, the left side. So, what's a number that represents x, or 1 to the left? It's a number that's very close, but let's not be like painfully close. 1 to the left. 2 is from the right first off. Like 0.9, just be off by a tenth. If I plug in a 0.9, do I get a positive number or a negative number? Because that's all I care about. If I plug in a 0.9, so the top is going to be negative no matter what, and then the bottom is 0.9 minus 1 squared, which will always be positive. So it's negative over positive, which is? So this gives me a negative value. Let's plug in a 1 from the right. What's a number like that's to the right of 1? 1.1. You plug in a 1.1, still got that negative on top, and then you're going to get 1.1 minus 1, which is 0.1 squared, which is still positive. So you're going to get a negative. So what's this answer going to be? Negative infinity. Did you do this in pre-calculus or no? So half of you were saying yes, so.
Yeah, the way we did it, you just made us like make a table and then calculate the values from like
Oh, okay, so you did that. It's called the Tabular Method. So. Tabular Method is effective, but if you don't have a calculator and it's like one like this, all I'm doing, it's the Tabular Method, but instead of doing all of the values out wide, I'm just doing just one right and one left. So it's kind of the same thing. All right. So let's just go to this now. So let's go back to 41. This is only looking for 1 to the left. Okay? What happens if I plug in a 1 right away? 1 over 0. So I'm either going to have infinity, negative infinity, or it does not exist. Since I'm coming in 1 to the left, I can't have does not exist. That won't happen. Okay? So I just care about if it's positive infinity or if it's negative infinity. So what's the number that's 1 to the left? 0.9. I'm going to get 1 over, what's 0.9 minus 1? Like negative 0.1. So this is going to be negative. So the answer is negative infinity. 42. Plugging in a 1, I'm going to get number over 0. Okay? This is 1 from the right. What's the number that's to the right of 1? Yeah, focus this a little more. So let's plug in like a 1 to the right is going to be 1.1, which is going to give me a positive value. I don't care what the exact number is. I just care that it's positive. So this answer is going to be positive infinity, or you can just write just the infinity. All right, 44. Can I plug in a 1? No. Now if I get a 0 over 0, I factor and cancel or do one of my techniques. I don't have 0 over 0. This is going to be a number over 0. So I'm going to plug in a 1 to the left, a 0.9. So 0.9 squared, I don't know, what is that? Like a 0.81 minus, what's 3 times 0.9? 0.27 or 2.7? 2.7. I heard someone say each of them. And then on the bottom, I'm going to get 0.9 minus 1, which is negative 0.1. The top is positive or negative? It's going to be negative. The bottom is negative, so the answer is going to be positive. So my final answer is positive infinity. And it's going to be the same thing for 45. Do you want me to go through 45 with you or just move on? It's just plugging in into more things. Just do it. Alright, let's just do it. Plug in at negative 3, you're going to get a number over 0. So let's go ahead and plug in, right, because I'm going to get 9 plus 3 minus 2. Yeah, it's a number over 0. The bottom's going to give me a 0. So I'm going to plug in, what's the number that's to the right of negative 3? negative 2.9. So this is to the right of negative 3. This would be kind of weird on the top. It would be totally awesome if you could factor it, because then it's easier to plug in a negative 0.29. Do you agree? Much easier. So does the top factor? How's it factor? X minus 2, x plus 1. Does the bottom factor? Plus 3, plus 1. So, actually, there's a hole at negative 1. Is that going to change my answer? No, I don't care about negative 1. But it's much easier to plug this in now, isn't it? So when I plug in a negative 2.9, the top becomes negative, the bottom is, so my answer is, I'm going to get a negative, so this means my answer is negative infinity. So that's talking about vertical asymptotes. You get vertical asymptotes when you get either infinity or negative infinity as your answers, or does not exist. Alright, 46. It says to graph it. Let's just do the same thing. Let's just use our device to graph it. I don't want to waste your time graphing it. So go to your handy dandy calculator and graph this guy. All right, so here's my graph. Let's answer these two questions. Now we're going to go out to infinity. That means end behavior. Positive infinity is the right end behavior, and negative infinity is the left end behavior. So the first one, this is going to be a right end behavior. And you're going to get a horizontal asymptote if you get a number. So if you have a number, that means you have a horizontal asymptote. If you get like infinity or negative infinity, then there's no horizontal asymptote. Okay? And we'll talk about horizontal asymptotes a little bit more. So let's go to the right side. So we're going to hit the trace button. Let's just keep going to the right and see what happens here. Getting closer and closer to what number? And I'm looking for y values, of course. Let's look at my y values. Getting closer. I can even move it over. Yeah, is it ever going to pass 3? Let's find out. Here it comes. Here it comes. Oh, yeah. It's coming. I'm going to break my phone by holding onto it. Oh, no. Never going to happen? It's going to happen? The rest of the class has just hold this down. Okay, fine, it's 3. All right, there. I made my window bigger. It's still not going to happen. So there, it's never going to happen. So it's 3. So it's the left-hand side. Trace, now go to the left-hand side. So looking at that y, it's getting closer and closer to what number? Alright, so on my graph, I've already moved it over a lot. So what happens is I'm going further and further to the left. It's closer and closer to what? So it's going to be 3. So, let's talk about how to find horizontal asymptotes. Okay? You probably learned this terrible thing called Bobo. Alright, let's talk about Bobo button. Let's not talk about Bobo button, it doesn't work. Can I give you an example where it doesn't work? Okay. Here, I'll do it on the back side. Alright, so let's Bobo button our way out of this one. Aww, you can't. Bobo button doesn't work. So what do? You go back to your old teacher and tell her, what were you saying? Now, I'll tell my classes Bobo button and pre-calculus, and I'll say that's not really true, though. But for your purposes, it is. I can't say that to you. Bobo button will work for most problems, but in calculus, we have extra problems, such as the one that I just wrote down that you have to be able to do. So what you have to do for this is, when you're going to infinity, you have to multiply. This is it. It's one step. It's not Bobo button. Here's all these different things you can do. It's one step. So multiply every term by the reciprocal of the highest increasing function. So to you, that would be like, oh, this power is higher. That's the one I care about. Kind of sort of the same deal, except in calculus, we don't deal with just x squareds and cubes. We're going to start dealing with e's and ln's and factorials and stuff like that. Well, maybe BC does factorials. You don't, but... Okay, so what does that look like? Well, let's go back over here. For 47, I'm going out to infinity. So what's my highest increasing function? Is it a constant value 1 or is it x? It's x. X increases faster than a constant because a constant does not increase. Does that make sense? Constant does not increase. So it'll multiply everything by 1 over x. Okay? So now when I do that, what's 2x times 1 over x? It's 2 minus 1 over x all over 1 plus 1 over x. Now here's the part of Bobo button that is actually true is the Bobo part. If the function on bottom is increasing faster than the function on top, you get a 0. Is that true? So for here, our 1 over x's become zeros. So this is going to get zeroed out right here, and this is going to get zeroed out right here, which is going to give me approaches infinity of 2. Because it's 2 over 1, right? So the answer is 2. And that's going to give me a horizontal asymptote. Yeah, because it's bigger on the bottom, so it's going to get zeroed out. Okay, let's do 48. So for 48 here, there's two ways to do it. You can either make this into one big fraction or just do these two problems separately. And just if you get it does not exist, then you can't do it separately. So let's just kind of hope we don't get that. So can I do them separately? I'm writing it down, so the answer is yes. Okay, so the first one, what's the limit of any x approaches anything of 5? It's 5. Minus, we can bobo this one, right? Because the x squared on the bottom is bigger. So we're good to go ahead and bobo this one. So this becomes a 0, so the answer is 5. So my horizontal asymptote for this one, by the way, would be y equals 5. $49. What's my highest increasing function? 1 over, well, it's x squared, so we multiply everything by 1 over x squared. So this becomes the limit as x approaches infinity of 2 over x plus 5 over x squared all over 3 plus 1 over x squared. Happens to those two terms in the top. They zero out. So I'm going to get 0 plus 0 over 3 plus 0. Answer is 0. I'm not going to do all these because they get a little repetitious. I'll do the next two, and then I'll probably do the ones where it goes up to negative infinity. And then my favorite problem is the last one. So for number 50, why don't you actually try this one on your own for 50? You could probably bow a button your way out of this one, but... And if you're cool with that, I mean, I guess that's fine. But there'll be problems that you can't bow a button your way out of it. So I just kind of want you to understand how to do these problems. All right, 51. If you're a bow a button 51, what do you get? Let's do it the real way. What's the highest power? X cubed. So multiply by 1 over x cubed. So I'm going to get 2 plus 5 over x cubed. And then 3 over x plus 1 over x cubed. Please notice how that becomes up on 3 over x now. Because the x squares and the cubes. 2 of the x's cancel out, one's still there. So now what happens? You're going to get 2 plus 0 over 0 plus 0, which is 2 over 0. Anytime we have an over 0, we have what are our options? Infinity, negative infinity, or does not exist. So, no matter what number I plug in, I'm going to get a positive on the top. You agree? So what kind of infinity is this one? It's positive infinity. So So this is actually equal to positive infinity. Bobo button didn't work. You would have put the wrong answer. What that means is the Bobo button, what it really means is for like just rational functions, the whole purpose of it is that there's no horizontal asymptote then. If you get infinity or negative infinity, there's no horizontal asymptote. That's the purpose of it. So I don't want to completely like, I don't know, make fun of what you've learned before. I just want to be able to put it to good use though. That's the purpose of it. And it's totally cool in pre-calculus because you don't deal with like weird functions that increase faster than other functions. Yes?
So, you mean, when you, like, make it 0, like, shouldn't it be, like, 2.0 and 0.0, right? And then this 2 over here, shouldn't it be, like,
Right, but it goes somewhere though. This function goes somewhere as you go out to infinity, the end behavior. It doesn't just, it either goes to positive infinity, or it goes to negative infinity, or it oscillates. Those are the choices. And this is actually going to be a slant asymptote. Did you talk about it last year, slant asymptotes? Okay. This is actually a slant asymptote. So since there's a slant asymptote, it either goes top or bottom. Okay? Now, if this was going to negative infinity, let's talk about that real quick. If this was a negative infinity, answer would actually be it approaches negative infinity. Okay? It's an odd function. Do you remember doing your functions last year with odd functions that are positive? Down, up. You remember that? Down, up? No? Yeah, the dance? Oh, the dance. Beautiful. So, hey, bring it back up here, please. To quickly talk about that, so if it's an odd function, this is an odd positive function. You agree? All odd positive functions do this with some twists and twirls in between. So as we approach positive infinity, we're going to get infinity. As we approach negative infinity, we're going to get negative infinity. Okay? So just kind of be aware of that. If this 2 on top was a negative 2, how would this answer change? It'd be negative infinity instead. Because it'd be odd negative. Alright, let's go down to, let's go do 53. So try the first couple steps on your own, we'll come back and talk about it. Does your work match mine? So what kind of infinity is this one going to be? Yeah, I agree. Why is it negative infinity? Yeah, this one is an odd function. Some of you are probably thinking, well, wait a minute, it says squared up top. That's not cool. Well, when you divide everything, you get zeroed out. 2 is an even function. It's even powered. The even power is 0. 0 is an even number. So if this was a cubed up here, then yeah, that'd be different. All right, so this one's going to be an odd function. This is odd. All right, let's talk about sine. So let's approach x goes to infinity of sine of x. What does sine of x look like? Who remembers? With your fingers. Yeah, like this. Neelish, what are you? Oh, there you go. That's better. I like that. What happens is you go out to infinity with sine? I love that word. It oscillates because it's not going to positive infinity or negative infinity. This line looks like this. Going on forever and ever. It doesn't change. So this is going to be, what's our answer then? It oscillates. That's not an answer. It's DNE. Why is it DNE?
Because it oscillates.
Yeah, it's good enough for me. Because the function oscillates. Alright, I'm skipping this 55 and doing my 55. Alright, last problem, and then I'm going to work on a worksheet for a little bit. We'll come back for a skills check just to see where we're at, not for a grade, but to see where we're at. And then we'll talk about the test. You have it, and I gave you everything you need already anyway. Yes. Okay. So let's go ahead and, does BoboBot work on this one? Yeah. It does. No, it doesn't. What's the highest? This is kind of a weird question. What's the highest power here? It's actually x. Okay. In order to multiply inside of a square root, I have to actually have a square root. So I have to push out a square root. So multiply by 1 over the square root of x squared. I have to multiply at the top by 1 over square root of x squared, because what does that simplify to? 1 over x. This gives me the opportunity to push this inside. And then on the bottom, I'm going to multiply by 1 over x. Okay? Are these the same thing? So can I do this? This is a legal move. Okay. Well, sort of, kind of. Technically, the square root of x squared, technically that's the absolute value. Did you learn that last year? Yes? No? Alright, well, technically it's the absolute value. So since we're going to positive infinity, absolute value doesn't matter. So if we were going to negative infinity, our answer would change, but that's more BC-ish. That's not us. We're AB. So we're going to push this inside. So this is going to turn into the square root of 4x squared over x squared plus 1 over x squared. All over. The bottom becomes 3x over x minus 5 over x. I am showing more steps for this problem, by the way. So how's the top simplify? You're going to get 4 plus 0. All over. What happens to the bottom? 3 minus 0. What's 4 plus 0? Square root of 4. Bottom is? Final answer. BoboBot, would it work there? Of course not. Hey, do you want to do this problem, by the way, that I kind of did? Said you can't BoboBot in it? Sure. As we're going out to infinity, what's increasing more? E to the x or e to the negative x? Here's e to the x. E to the negative x actually goes this way. E to the negative x goes that way. So which one's increasing faster? E to the x. Multiply everything by 1 over e to the x. So I'm going to get 1 plus... Well, e to the negative x is really 1 over e to the x, right? So this is really e to the 2x all over 1 minus 1 over e to the 2x. Since the bottom right here is increasing faster, these just get zeroed out. So what's your answer? 1. Eat your heart out there, BoboBot.